welcome to the channel Base Your Btech. So let us continue solving mechanics question paper. As I have said in the previous video, there is one question which is frequently coming in your exams, that is to find the resultant force. Okay, to find the resultant force. Here in this question, 9th a system of 3 forces acting on a body is shown in the figure. Determine the magnitude, direction and position of the resultant force with respect to A. That is, you are given with a diagram which is a square named ABCD, and at the points B, C and D you are having 3 forces. Okay. So if you are having more than one force, then it means that we can have one single force which can balance all these 3 forces. Okay. So that is what we call as resultant force, and we need to find the magnitude, direction. Also we have to locate the position of the resultant force with respect to A. Okay. So let us try solving this. I have copied it. So let us start. First of all, you need to paste this figure in the first quadrant of XY coordinate system. You see a positive y-axis, negative y-axis. Also here it goes positive x-axis and negative x-axis. Okay. Next is, please highlight your forces. 100 kilonewton here, 200 here, and another 150 is acting along here. Except this 150 kilonewton, both others are inclined somewhat, isn't it? Along x-axis, the inclination is 45 degree for the 100 kilonewton force, and for 200 kilonewton, it is 30 degree inclined. So the next step is you have to resolve these inclined forces along horizontal and vertical axis. So before that, I will give you a short recap about the resolution of forces along two mutually perpendicular axes. Okay. That is, if you have an inclined force which is of magnitude A, and you need to resolve the same in two mutually perpendicular axes, let it be x-axis and y-axis. Also please note that this vector A is theta degree inclined to x-axis, then your x-axis component will be A cos theta. See why I put this in bar means it indicates the magnitude of A. Okay. And the component along y-axis, this much quantity is A sin theta. So please just notice that whichever side is nearer to theta, then cosine component will go, and whichever side is away from theta, sine component is the magnitude of that particular side. So here in this case, you can resolve this 100 kilonewton along this negative x-axis and negative y-axis. Also 200 is resolved along positive y-axis and positive x-axis. So let us have the magnitude along, the component of 100 kilonewton along negative x-axis. It is, see this side is nearer to 45 degrees. So cosine component must be written here, which means this is actually 100 cos 45. But since we have resolved along negative x-axis, a negative sign comes here. And also here this side is away from 45, so this is 100 sin 45, and here we have to put a negative sign because this arrow is pointing in negative y direction. And here again 200 kilonewton, and it is 30 degree inclined along positive x side, isn't it? So this is 200 cos theta, cos 30, because this side is nearer to 30, and about this side which is opposite or away from 30, here we have 200 sin 30. Both are having positive sign because they are directed towards positive y-axis and positive x-axis. See, if you have any confusion to put the sign, I will give you a trick, like not actually a trick. If the force is along upside and right side, then it is positive, put a positive sign, and if the force is along downside and left side, put a negative there. See, example, 100 kilonewton resolution of forces was along left side and downside. That is why we are having negative here. and about 200 kilonewton, it is resolved along positive x-axis and positive y-axis, or it is resolved along upside and right side, so that we have positive sign here. Okay. So, and what about 150 kilonewton? There is nothing to resolve this 150 because it is already along the positive x-axis. So, why need resolving? No. Okay. So, in total you are having 5 forces. Okay. Then your very next step in your answering is you have to find sigma fx. Sigma fx is add every component of forces which is along plus or minus x-axis. Okay, that is all horizontal axis components should be added. Here you have negative 100 cos 45 and plus 200 cos 30 and this 150. So your value is about 252.5 kilonewtons because the unit for every forces is kilonewtons. And next, sigma Fy is add every vertical forces. Here it goes negative 100 sin 45 and positive 200 sin 30 and nothing along vertical direction for 150 kilonewton. So let it be, and we have after addition the value is 29.3 kilonewton again. Okay, now the resultant force. Okay, the magnitude of resultant force R is equal to root of sigma Fx square plus sigma Fy square, the same formula which we had in the previous video. Just substitute them, square up and add it, take its root. Okay, so the value is about 254.2 kilonewton. Okay, and next thing is, so 1/3 of the question is over, that is to find the magnitude. It is about 254.2 kilonewton. One part is over. By this time you will score out of 7, you would score about 3 marks. So the next part is to find the direction of the resultant. Direction of resultant R. The formula is tan theta is equal to sigma Fy divided by sigma Fx. Your value for theta is about 6.618 degree. Before you calculate this, you have to make sure that your calculator is set in degree mode. Okay. So this 6.618 indicates that your position of the resultant is somewhat 6.618 degree anti-clockwise direction. Somewhat here, or it can be here, or it can be here. Anyway, it is inclined 6.6 degree along positive x direction. Okay, so your theta value 6.618. I think you can add one statement like the resultant is 6.618 degree measured in counterclockwise direction from positive x-axis. Okay, from positive x-axis you measure your resultant about 6.618 degree in a counterclockwise direction. That's it. And the third part of the question is to find the position of the resultant force. Okay, in order to find that, you need to actually draw this figure once again, but this time you need not want to draw it in a coordinate system. Let it be as such. And here the next step is to find sigma m. You know what is this? This is sigma moment. Moment of all the forces you have about A, because the question is to find everything with respect to A. So moment of forces about A. Also this moment is equal to force into perpendicular distance. Okay, and this perpendicular distance is with respect to A. Okay, perpendicular distance to A. For this question it is perpendicular distance with respect to A. Okay, so here is your point A and you have got many forces, isn't it? I will draw every forces resolved. So this is the diagram, and this time I have not put positive or negative sign. So here, while finding the moment, you just avoid putting signs. Okay, just avoid putting negative or positive signs. Unlike in the previous case we had positive and negative signs along with the components, because there we have our aim was to find the resultant and direction and all. But here we have to find the moment. So here we are having a different sign convention, like for clockwise direction, please have a negative sign, and for counterclockwise, anti-clockwise direction, please have a positive sign. This is the sign convention which I am following. You can follow in your way also, that is your choice. But let us follow like this, because why I chose this mode, because usually angle is always taken positive when it is measured counterclockwise direction, and it is negative when it is anti-clockwise direction. So let us find every moment contributed by these forces. How many forces are there? 1, 2, 3, 4 and 5. So for these 5 forces we are having 5 moments. Okay. So let us find out it. First of all, let us find the moment contributed by 100 cos 45. And the equation is force into perpendicular distance to A. What is the force? It is 100 cos 45. So it is about 100 cos 45. And what is the perpendicular distance of the particular force with respect to A? In order to find that, you must draw a line of force. Just extend your force. And while you extend, please cover this point A. That's it. That's the only aim for us. While you extend, you have to extend till the point A is covered up. Okay. Now you can find the perpendicular distance, like this is your perpendicular distance from the point A to the line of force. Okay. What's the length? It is 1 meter. So it is actually 100 cos 45 into 1. Okay. So force into perpendicular distance is ready now. Now you have to go for the sign convention. See, for that you can notice that this arrow is going like this. So how can the 100 cos 45 force cover A? It can cover in a counterclockwise direction. That is why we are having a positive sign here. Okay. And the next part, and let us take the next part, which is 100 sin 45. So 100 sin 45 is passing through the point A. So there is no perpendicular distance between this force and A, because it is actually this line of force is passing through A. So how can we measure the distance between A and this yellow line? So there is no moment contributed by any force which is passing about our point. Okay. So we will have no moment for this 100 sin 45. Next is 200 cos 30. Okay. 200 cos 30. You are having 200 cos 30. And what about the distance? What about the distance of this 200 cos 30 with respect to A? Just extend this line of force. Just extend this line of force till it cover the point considered. See, now it is okay. This line is extended. I mean, this 200 cos 30 is extended till we cover up this point A. And now you can measure the distance between A and this yellow line, which is again 1 meter. So this is actually 200 cos 30 into 1. Now what about the sign convention? Here you can see this arrow can cover the point A in a clockwise direction. So we should put a negative sign here. Okay. So let us move on to next force. Okay, so our next force is 200 sin 30. So let us write 200 sin 30. And to find the perpendicular distance, just draw the line of force first. Just extend your 200 sin 30 till you cover up your point A. Now the perpendicular distance is like this way, and again it is a square, so here also 1 meter. So 200 sin 30 into 1. Okay, now how can this 200 sin 30 cover up this A part? Along again a counterclockwise direction, so we need to put a positive here. Okay, and lastly, what about 150 kilonewton? 150 kilonewton, you can see again here that this 150 kilonewton when extended, it passes along this point A, isn't it? So there is no perpendicular distance available, so there is no contribution of moment by 150 kilonewton. So this is your sigma m. Okay, add it up and you will get it as minus 2.5 kilonewton meter is your sigma m. What does this actually indicate? This indicates that your moment is 2.5 kilonewton meter and this negative represents it is a clockwise moment. So it is a clockwise moment. Okay. Thus we have found out sigma m value too. Okay. Next step is to find the location of your resultant force. Location of your resultant force. Okay. For that there is a formula available like sigma m is equal to resultant force into R. Okay. This R indicates the position of your resultant force. So you have the value with value of sigma m and also the value of R. So substitute like 2.5 kilonewton meter is equal to R. R value is about 254.2 kilonewton into R and your R value is about 9.8 millimeter. 9.8 millimeter. So I think by this you can complete your answering, that you can conclude by writing this line that the resultant force is 9.8 millimeter away from point A. Okay. Actually your answering ends here and you can move on to the next question, but if time permits you can have an extension for this answer. Actually till you do up to this you can score about 6 marks and all, but for completion you have to picturize all the values again in that square diagram. Okay, I will tell you that. See, I have brought every values here and also plot the figure again. Now you have to locate this R with respect to A. So I put a dot at the point A and I am going to draw a circle with center A and radius 9.8 millimeter. And look for the moment, it is clockwise direction. So your vector or your resultant force should make a clockwise rotation about this A. Your resultant can be somewhere here. See, this arrow can be a resultant because it is making a clockwise rotation about A. Also your resultant can have a different direction like this because it is also making a clockwise rotation, and your resultant can be this way or this way or this way, and we have to choose out of these arrows which is your resultant. For that you have to take this 6.618 degree. See, 6.618 degree is measured counterclockwise, isn't it? That is why we are having a positive sign here. So counterclockwise measured 6.68 degree, it is actually somewhat in this way. So we can choose some vector which is parallel to this direction. That means I think this vector will be suitable, isn't it? We can rub the others because all other arrows are making different angles with respect to x-axis, but we need one which is having 6.68 degree with respect to x-axis. Okay, and also you can confirm that this particular arrow is how much distance away from the point A. It is 9.8 millimeter away. So your answer is, this is your resultant R. Okay, when you extend this x-axis you can find that this is your resultant R is making 6.68 degree. Also you can have that this your resultant R is making 9.8 millimeter away from point A. So this is how you can reach up to 7 marks. Actually this portion is somewhat lengthier. You have to consider your time also. So please skip this part and you can stop your answer while you get your R value, and you can conclude till here. Okay, R force is 9.8 millimeter away from point A. So that's all for today's session. If you like the video, please like, share and subscribe it. Till we meet in the next class, this is Minu signing off. Thank you and take care.